Okay.
Sir, shall we start?
Wait. Jyoti? Jyoti?
Sir, I'll be the one moderating it, sir. My name is Mohammed Razi.
Okay, can ask Jyoti to start.
Sir, the session will be moderated by Mohammed Razin.
Okay. Okay, Razin?
Yes, sir. Shall we start?
Yeah, you can.
Oh, okay, thanks. So, good evening, all. I extend a warm welcome to all of you gathered here for the weekly webinar series conducted by IEEE KMCT in association with IEEE Malabar subsection of IEEE Malabar Hub for the 92nd webinar on the topic network control, the future processor for its IT technology. Today, we are honored to have with us Dr. Ashok Kumar K, Assistant Professor, Department of ECE, who is a staff from Matrusri Engineering College, Hyderabad. With huge respect and admiration, I hereby invite Dr. Ashok K. Kumar to the session. Dr. Ashok Kumar K is currently working as Assistant Professor in ECE Department. He is a PhD holder in VLSI and has both academic and research experiences. He has published 20 research papers at international conferences and journals. Dr. Ashok also has produced one Indian patent. He is a fellow member of IETE and lifetime member of ISVLSI. His research also includes IOT, AI, and VLSI. I hereby also welcome Dr. Sabik PV of Sabik PV, Chair of IEEE Malabar. I also invite Dr. Sabik PV, Chair of IEEE Malabar Subsection and also Principal of KMCT College of Engineering for Women. So a hearty welcome to you too, sir. So with huge respect and admiration, I call upon Dr. Ashok Kumar K to start our discussion. So over to you.
Yeah. Thank you with a nice introduction, and thank you for Sabik sir is giving the good opportunity for sharing the knowledge which I gained when I done my research. Okay, I can share my screen. Yeah, hope everybody got my screen.
Yes, Ashok.
Yeah.
Yes, sir.
Yeah, thank you. So today I am going to discuss the very important processor and VLSI based processor, which is what are the advancement of processors in VLSI. And as the basics, most of the people will know. So I will go little from the SOC onwards. So system on chip. So today, these are the contents I want to share for today's webinar. So it starts with what are the any one application will requirements, what is the present requirements, and what how the FPGA or how the processor is requiring the requirements of the application, and what are the critical problems addressing in the NOC, nothing but what are the problems you are facing when you are designing, and how level the data is moving from one layer to another layer, and how the networking modeling in the network on chip, and finally we'll conclude with the network on chip simple architecture. So that architecture you can use for the network internet based applications or AI based applications, big data, these things. And so this is the first slide and applications of application requirements. So there are basically, if you broadly define classified, so there will be three types of applications will be there. So signal processing applications and media processing and multimedia processing applications. So basically, if you see the applications oriented based ICs or processors, so signal processing applications, mostly the DSP based processors can be used. That is digital signal processor based ICs or processors can be used. Whereas media processing, and here SOC or media process can be used, and multimedia. So PCs and with desktops based processors are uh, integrated of all the versions you can use in the multimedia based application. So how the future internet is depending on the ICs. So mostly whenever if you compare with the 1 decade before, so the internet speed also will be less. So by the speed of the processor. Nowadays, when you are going for the 4G or 5G, even after five years, you may see the 6G. So whenever the generations are increasing, so there will be the speed. Obviously, the internet speed also going to be increased. So, however, you can increase the spectrum, but whenever you have the high-end processor, if you have the high-speed processor, then only you can able to compatible that 4G or 5G or 6G, that speed you can able to get in your PC or mobile phone. So if you see how you are going to get future in internet, nothing but you must using the more number of packets, and that packet should be processed by using the uh, ASICs. So ASIC is nothing but so application specific integrated IC. So these type of ICs as well as general purpose processors combined together, you will get the high speed internet. So if you want to get the ASICs with the general purpose processors, you must go with the multi chip SOC, multi chip SOC. So those who are when you are hearing the first time SOC is nothing but system on chip. So it is within the chip, you will get everything. It may be processors, memories, and timers, and A to D converters, D to A converters, and mixed signal processors, analog signal processors. So various type of processors and various types of memories and integrated IOs, all the components will be presented in one place. That is nothing but system on chip. So where the system on chip is included with multi-core, nothing but you are going to dividing the SOC in terms of number of subcores. So each core can act as a one processor. Okay, so nothing but each core you can assign one job. So one core is dealing with the internet, one core is doing the another arithmetical logical operations, one core is going to be video processing. Nothing but when you are having the multiple cores, you can do the processor with multiple tasks. So these are main advantage of the system on chip to multi-core system on chip. So whenever you are going for the network processor, basically the network processor is one kind of multi-core processor. If you see the multi-core processor, there will be two processors will be there, co-processor as well as basic processor. So here the PE is indicating that processing element. So processing element is nothing but you can take it as a either processor or memory or IO device. So these any one of the memory or IO or processor is integrating or is interfacing with the co-processor by using of internet network interface. So that network interface is designed such a way that it can able to communicate the information from the PE to co-processor and co-processor to PE. So as I mentioned, the PE may be SRAM. If you see the example of network processor based applications, So you network processor based applications majorly used in the networking. So where you can see the core router and edge router and VPN gateway. So by using of these all the components, all the processors is connected with a common platform or common mode, that is internet. So internet is our internetworking. So internetworking is it is a very important communication interfacing device which can able to communicate core processor to edge processor, or core processor to VPN gateway, or edge processor to VPN gateway. However, if the data is going to be moving from one device to another device, it must able to having the efficient internet working protocol or efficient internet working architecture. Then only you can able to get the high end of speed. Okay, so when another slide, when you are going for the telecommunication system, another side of the applications. So is the telecommunication system will have the four components. One, you can use the task based on the software and the processor executing the software, and specific hardware cores, as well as global on-chip communication network. So when you are going for the all the four types of components in telecommunication network, so this one is a very challenging issue in the telecommunication, which one global on-chip communication, because when you are having the system on chip, thousands and millions of components in one place, so there will be communication will be very difficult. So how it is going to be difficult, and how way you can compensating those difficulties by using network on chip, that we can see in the further slides. So technological architecture trends. So when you are going for the, if you see any VLSI based technology, the technology is going to be day to day, it is going to be reduced. So when you are going to see initially 180 nanometers of channel length will be there, then 90 meters, now 45 meters, 27 meters are now presently working on 7 nanometer technology. So the technology is reducing day by day. So nothing but processor, the area of the processor is reducing day by day, but the number of components are increasing day by day. So however, the area and number of components is inversely proportional. So when the number of components are increasing, usually we have to think of the area also going to be increased. But here, if you are made up of any component or any processor based on VLSI technology, so it should satisfy the Moore's law. So Moore's law is nothing but whenever the number of components are going to be double for every 18 months or every 1.5 year. So every 1.5 year, the components in a IC, it is going to be double. So that is a Moore's law, and which should satisfy the VLSI technology. So whenever you are transferring the data from one device to another device, you must face some communication issues. So what are the communication issues you can face from when you are transferring one processor to memory, or one processor to another processor? Usually the difficulties we can face in terms of timing errors, you can in terms of crosstalk and EMI and soft errors, right? So these are all the timing errors is nothing but you can have the slight edge of when you are transmitting the data, it may be in terms of ones and zeros. Same ones and zeros you can't receive at the destination, because of there will be a communication problem. Crosstalk also, when you are sending the data, something is data is overlapped. So because of overlap, you can have the crosstalk of issues. Similarly, EMI and soft errors. So these are the basic difficulties you can face when the data is communication from one node to another. So how the different way of on-chip communications are there? So what are the how the communications are started? So initially, when you are going for the microcontroller or 8051 microcontroller onwards, so you can see the nodes will be presented in one place to another place. So these in between of two nodes, or in between of one processor to one memory, you must have the communication between one point to another point. So for example, here you can see the IO device and P1, P2, P3, these are the nodes, these are the IO device, and this is the memory. So these devices are going to be connected one to other by using of dedicated communication. Dedicated communication, because IO to P1 is one communication, and P1 to P3, and P1 to P2, and memory to memory interface to P2. So these are the way of communication which is used in initial days. So this is nothing but point to point communication, nothing but the source will be in one point, destination will be another point. So in between you have the number of intermediate nodes is there. These, through the intermediate nodes, the data is going to be moved from source to destination. So this is the present way of communication. So you can see here. So from one node to another node, the data is going to be communicated. And if you are having this type of communication, what are the problems you can face? So basically, this type of communication requires the number of communication links will be more. So you can see here black color and red color. So these are the number of links are requiring more. So whenever you would get the more number of links, so each link requires certain amount of power. So those leakage power and thermal power is going to be increases, which leads to your chip is deperformance. So this is not, maybe it would have suitable when you have the on chip, when you have the number of components will be limited. If you have the limited components, then this point of this way of communication may be this way of communication is suitable when the number of devices are limited. And next way of communication will be bus communication or shared bus communication. So there will be a lot of components are there. So all the components are connected with a bus. So P1, P2, P3, and IO memories. So there are all the components are connected through a bus. So if we have the single bus, so it can able to provide the connection between any two devices only. So at particular time, any other device is going to be, it's want to communicate, it should be in the waiting position. So there is the communication delay or data transferring delay will be more in the shared bus communication. So another type of communication, hierarchical bus. So hierarchical bus is nothing but there will be two buses. There will be two buses. One bus is connected to one or certain components, and another bus is connected to certain components. There will be a bridge between one bus to another bus, because whenever one component of particular bus and another component of another bus want to communicate, it has to go through the bridge. So here you can see how the components are moving from one bus to another bus. Here also there will be communication delay will be increases because of two buses are there, but number of components are more. So another type of communication will be, so this is the matrix communication. So the matrix communication, you can see there will be two vertical, the shape of the it will be comes under the star shape. But however, here there will be a lot of connection links will be required. So because of these links, so that data may be misrouted or that data may be affected with errors. So this is the architecture. This is the way. This is the communication protocol we are looking for. So the parallel way of sending the data. So here the network on chip, the architecture will be. So whenever you are having the multiple nodes want to communicate with the multiple nodes, you must go with the parallel way of transferring the data. So how the data is transferring, you can see. So all PEs is communicated with all PEs. So each node is able to communicate with another one, and there is no delay is affected, and connections also very limited, but you can provide the service to number of components. So the power consumption will be less and delay will be less in the way of in this type of communication. So you can see, so all the devices. So here PEs are nothing but, again I am repeating, PEs are nothing but it may be processor, it may be memory, or it may be IO device. And if this one is acting as a source, PE1 is acting as a source, so it should go with another PE through the routers. Here R mentioned, R it is nothing but router. So through the routers, the packet or data is routed in proper direction and it will goes to the destination. So what are the traditional SOC will have the difficulties? So if you see the traditional SOCs, so the traditional SOCs will have the dedicated interfaces are nothing but dedicated connections. So that dedicated connections you can't use for the another purpose or another the connection between other nodes. So that is another one of the difficulty, and designing and verification also complex. So these are all the major drawbacks or nightmares in the system on chip. So the network on chip is new paradigm for the SOC, or again I am repeating, network on chip is the communication protocol for the SOC. So when you are having the multiple number of processors, so these processors are going to be communicated with one to other by using of network on chip. So these are the dedicated bytes and given to the shared network. So you can see the example of the network on chip, how it will be. So this is the network on chip, which is given in the blue color, and outside of the network on chip you can see the IO device, DRAM and Axle, CPU, network, DMA, DSP, net, Ethernet and DMA. These are all the components which is connected to the network on chip, and these you can able to, if DSP want to communicate with the DRAM. So first initially DSP has to send the data to through the NI, it has to come to the switch or router. So these switch, from the switch it will goes to another nearby switch. Through the nearby switch it will goes to DRAM. In same point of time, the CPU can able to communicate with motion MPEG, okay, motion pixel expert group. So these two also able to communicate, and DMA able to communicate with the CPU. So multiple communications will be happen in the NOC. So what are the essentials of NOC? So in the essentials, so NOC, you majorly only two components are required. That will be router or switch and interface. So if you see the example of the NOC, initially the CPU is communicating with IO device. Let you assume this is the path. So CPU is here and IO device is here. So from the CPU, it will come to the network interface. Through the network interface, it will come to the switch. This switch to, again, it will goes to this switch. From this switch, it will goes to the network interface of the IO. Then it will reaches to the IO. So this is the flow of data from CPU to IO. The same thing it is represented here. The CPU is given to the data. CPU is acting as a source and IO is acting as a destination. So CPU is giving the data to network interface. This network interface is able to convert the data, which is the switch is compatible data. How the switch is requiring the data, so that will be done in the network interface. So the data is comes to the switch. From the switch, nothing but it will coming into the network. So one switch to another switch, based on the routing protocols or based on the flow control protocols that we will discuss in the coming slides. So from one switch to another switch, the data will be go from the switch. Again, it will goes to the network interface of the destination node. Then through the network interface, it will reaches to the input and output device. So like this, you can able to see the data flow in the one CPU to source to destination through the NOC. In network interface, source network interface, you can see the data is going to be packetization or data, byte of data you are going to divide into bits. Again, in destination network interface, you can see the bit of data in the form of byte. So when you are designing the network interface, what are the critical problems we can able to see or we can able to face? So basically, as the number of connections are more in the network on chip, so you can able to see the global interconnect issues, design issues, as whenever you are going for the any kind of connecting issues like delay, power, noise, scalability, and reliability. So these are all the kind of problems you can face, but you can able to overcome these problems by using of new technologies when you apply to the network on chip. So similar kind of thing, system integration and multi-core processor. So these are all the common problems when you are going to designing the network on chip. You can able to face this, but you can overcome by using of new technologies. So this is the basic NOC and the communication reliability. How the basic network on chip will be looks like. So you can see the router. Apart from the router, you can have the network on chip. Okay, so here you can see router. Through the network on chip, it will come to the input buffer. So through the input buffer, you can able to apply the error detection and error correction methods. Through the once it is error corrected or detected and corrected, it will goes to the next level of doing the conversion, like reduction and parallel to serial converter, modulation, link interface. So these are all the things you can able to provide in the network on chip. So the layers of abstraction in network. Basically, what are the different networking layers you can use in the network on chip? So as usually, if you there will be two kind of network models. So ISO OSI layer and TCP by IP layer. So here most of the layers you are going to use from the ISO OSI layer. So first layer you are going to use software layers for the application and operating system. Then we will go for the network and transport layer. These layer is going to be very important for the network on chip, because when you are going to designing the network on chip, you can able to consider these parameters. The network topology. So which type of topology you are going to use, either mesh, torus. So and these I will discuss from the coming slides. And switching components. So which type of switching it is, circuit switching or packet switching or wormhole switching. Addressing, whether you are doing the logical addressing or physical addressing. And routing, which type of routings you are doing, static or dynamic. Quality of service, whether you are giving the guaranteed throughput or best effort. And congestion control and end-to-end flow control. So these are all the methods which we can see in the network and transport layer. So data link layer. So data link layer also we can use for the network on chip. That is flow control mechanisms and handling the contention problems, correction of transmission errors. So these are the basic functionalities of the data link layer, which we can use in the network, as well as physical layer. So physical layer is reserved for the writes and diverse transceivers. Okay. So basically these four layers we can use for the designing of the network on chip. So how to select the architecture for the future needs? So initially the FPGA architecture is started with ASICs. Initially it will go with the cells, memory cells or logic cells. Then from that it is moved to the ASICs. From the ASICs it came to the FPGA. So FPGAs to CMP, chip multi-processor or multi-core processor. Then it will come to the network on chip. Okay, then it will come to the network on chip. So these are the basic differences between the network on chip communication and bus-based communication. So always network on chip will be having the higher performance than the bus, but bus speed will be more, but it is not compatible to whenever the number of nodes will be more, or whenever the more number of processors will be in the system. See, bus communication will be the very basic communication. When you are having the only two devices, within the two devices, the bus is going to be travel the data from one node to another node. But if the number of nodes are going to increase, so bus is not able to provide the same performance in the which is you seen in the two devices in the system. However, we can see the same performance by using the network. So again, the comparison with the network on chip and off chip based networks, because some of the components or some of the interfacing protocols you can use for the off chip. So here network on chip, everything you are everything you are going to use in the on chip only. So when you are designing in CAD tools, so these are the basic problems you can see for any kind of VLSI circuit. So while mapping, application mapping, floor planning, routing, buffering size, timing closure, and simulation testing. These are all the basic problems when you are going to designing any kind of VLSI circuit. It may be from transistor to it may be CMOS transistor. So these are the problems in the network on chip, CAD problems in the network on chip. However, we can use the application mapping for core planning in the network, routing of the messages. Okay, so these are all the problems when you are going to applying for any kind of CAD tool. CAD tool is nothing but computer aided tool. So when you are implementing any circuits in the CAD tool, you can face this type of problem. So this is the basic kind of data abstractions. So this is the message in the form of packets. So this message, you can use packet as it is. If the architecture supports this packet, you can use divide into several sub packets and you can use it. The sub packets we can use in terms of flits. Flit is nothing but flow control unit. Flow control unit. So each packet we can able to split into, or we can split into three sub packets, nothing but header flit, body flit, and tail flit. Header flit is nothing but always it is responsible for the addressing, because header we can able to, once the header is reached to the destination, remaining body as follows from the body header. So once it is header is moving, body will follow. And tail flit, it can able to know that this is the end of the body flit, or it is the end of the packet. And these splits you can able to split into many groups, that is fits. Fit is nothing but physical unit. Fit is nothing but physical unit. So this fit you can able to give its type and sequence and virtual control and data. So this type of sequences you can use in the warm home control. Basically fit is usually we can take it as a one bit of memory, So this is a typical design flow of network on chip. So whereas here you can see the different kind of processors, maybe CPU, memory, IOs, and DMAs. So these are all the things it will be connected through each network. So here you can able to see the switches through the NI or network interface. So you can see it once it is organized and it is going. See, for some, if you want to communicate this IO to this, what it will do? Initially, it will send to the data to this switch. From this, it will goes to here and it will come to here. So that also we can able to analyze in this coming slides. So what are the basic requirements to design the network on chip? So network on chip, if you want to use, it must have the higher performance in terms of throughputs, latency, power. So throughput is nothing but how many nodes you can pass on in unit time. Latency nothing but how much delay you can get from source to destination. Power, so when the data transmission from source to destination, how much power it is going to use. Similarly, area, how much area it is going to use, as well as complex functionality, which is going to be support the virtual channel. I will tell you what is the virtual channel, because sometimes when you connected the source to destination, if you are connected physical wire, maybe that wire is blocked, or maybe that wire is blocked by some other functionality. So that time you have to create the channel or create the links virtually. So physical link is going to be divided into virtual links. Then you can able to transfer the data. But the drawback in the virtual links, you can able to use consume some more power than the physical link. Okay. So synchronization, you have to check the reliability, throughput, and low latency. So these are all the basic requirements of the network on chip. So how way network on chip is going to build? How way network on chip architecture is going to be built? So basically building blocks are, so topology. So depends on the topology you can decide, and routing mechanisms, control flow mechanisms, and network interface and router architecture. So these are all the 5 basic building blocks of the network on chip architecture. So first one, we can see the network topology. Topology is nothing but the physical arrangement of the nodes. How the physical arrangements nodes are structured. How the physical nodes are aligned. If you have the 10 number of nodes, how this 10 number of nodes are aligned. There will be 2 classifications: direct topologies and indirect topologies. So direct topologies are one of the best example of direct topology, mesh. You can see here. So these are the PEs are nothing but nodes. So in the mesh, you can see the X and Y model. So X direction and Y direction, X direction and Y direction, X direction and Y direction. So like that, in the mesh, all the nodes are aligned. So you can see the mesh. So this PE is acting as source now, and this PE is acting as destination. In the mesh, you can have the data transmission from, it will come to a router, then it will goes to through the router, again it will goes to the destination PE. So PE here, PE indicates nothing but it may be processor, it may be memory, and it may be IO device. Okay. So another type of topology, direct topology, which is torus. Torus topology is nothing but it is going to be give the connections in edge. So you can see here, it is very similar to mesh, but it is going to be connected to edge type. So this edge and this edge, again this edge and this edge. So like that, all the edges are connected. So here, how the data flow is be, this is acting as source and this is acting as destination. So how the communication will be, this packet has to come to this router, then it will move to here, again it will go here, from this it has to go like that, it has to. So you can see in the how the data is moving. So it is going to here and it is going to here. Okay, so the very similar configuration of mesh and torus, but edges are going to be connected. And the next one is folded torus. So very similar kind of torus, but here the torus is mirror image. Folded torus, nothing but. So whatever the torus configuration, here you are going to see the mirror image. So how the data is going to flowing here, you can see. So initially this is acting as source. So this is acting as source and this is acting as destination. So once if you see, the data flow will be like this. And another direct topology will be octagon. So the shape itself, it is telling the eight connections will be there. So each connection will have its own node and respective network interface. So how the connections or packets are moving, you can observe here. So first 2 packets are moving, next 1 packet, again 1 packet is moving, finally this packet also moving. So there is no disturbance from one to other. So this is also direct topology. But what is the differences of these all the things? So mesh, it is aligned in the form of XY, and torus, the XY is connected with the edges, and folded torus, the mirror image, and octagon, nothing but it is connected in the form of octagonal shape. So this is another kind of example, which is indirect way of topology. So indirect way of topology, you can see the PEs are connected, PEs are here. Now, any one of the PE is acting as source and any one of the PE is acting as destination. Now the connections are going to through switches. This packet will go here, then it will go here. From here it will divide to this or this, or from here it will divide to this or this. So this is indirect way of transferring the data. You can see. So data is transferring from one node to another node by using of tree mechanism. So this is under the classification of indirect topology. So how to select the topology? So these are all the number of topologies will be there. So how you are going to select in the topology? So if we have the few number of PEs, nothing but processors or memories, if it is in the form of tens, so mesh is recommended. If it is in the form of hundreds, so you can go with hierarchical sort. So these are based on the literature, we can give this conclusion. So next building block will be routing algorithm. So routing algorithm is nothing but how the packet is routing from source to destination. So let you assume, so this is a this is a source and this is a destination. So here the data can be moves from like this manner, or data is going to be moved first towards horizontal, then towards vertical. So or else it will go from first to vertical, then horizontal. So which way or which path, which route it can select for transferring from source to destination, that is nothing but routing. So there will be lot of algorithms are there. So the routing algorithms can decide, and routing algorithms, if it is efficient to routing algorithm, it must able to prevent deadlock, live lock, and starvation. So what is this deadlock and live lock? So these are the basic three problems when you face when the packet is moving from source to destination. You can able to see the basically three problems, that is deadlock and live lock and starvation. You can see by using of pictorial representation. So live lock is nothing but initially this block is this route is blocked, this one is blocked. So here you can see the red line indicates congested path, nothing but this is occupied with some other. So now the data is packet is to starts from source to destination. If the path will be like this, there is no disturbance. But if it is goes to in different direction, so how the live lock will be occur, you can see. So packet is misrouted and it will went in this loop. So continuously, because once it is entered the loop, the packet cannot come out of the loop, because this path is blocked, this one is blocked, and this one is blocked, and this one is this one. So all the paths surrounded by this path is blocked. So now only the option of the packet will be, it should be in the loop. It should be in the loop. So in this case, the packet is going to be experiencing the live lock error. So similarly, deadlock means you can see the packet is going from, this packet is going to destination 1 to, here the destination is there, and this packet is going to destination 0 to, this is a 0 to, this packet is going to 0 to again, and this is a destination 2 to after this. So once if you see the packet flow, now you can see the packets are started and it came to the nearby nodes. Next again the packets comes to the neighbor nodes. So some of the packets are reached, and now once this path is fully occupied, then this path is blocked and this is blocked and this is blocked. Now you can't able to transfer any kind of message within this all the nodes. So there is no new packet will come into these nodes. So this kind of situation or this kind of error, we can call it as a deadlock. So deadlock is nothing but, you can see here. So now these paths are empty. These are all empty. So once these are filled, so if the router is not taking, so it is not going to come with another one. So this type of situation, we can call it as a deadlock error. And what are the algorithm? If it is any kind of efficient algorithm, it should prevent or it should overcome these problems. So what are the different kind of algorithms are there, or what are the attributes you have to consider? So if you are selecting any kind of algorithm, you can see the number of destinations. Depends on the number of destination. The routing algorithms you can consider, that is unicast, nothing but single path. Multicast, nothing but you can go for the multiple paths. And broadcast, nothing but it is like flooding. All the paths will goes to only one destination. So another kind of attribute is adaptivity. Adaptivity is nothing but how level you are going for the shortest path. Then implementation. So source node implementation and destination. So these are all the sum of the routing algorithm. When you are going to choose the algorithm, you have to consider these parameters. So first one, source and adaptive routing. How the source and how the adaptive, sorry, static and adaptive. Static is nothing but, so the routing algorithm is, it is fixed one. So there is no change in path once the data is started, once the packet is started from the source. So it can, once the path is fixed, then only the static algorithm will. Whereas adaptive, you can see the dynamically change in path that you can observe here. So static path, here conjunction is there, but still it is going to go in this path here. But whenever you can see here, the path is packet is started here, but whenever you can see the conjunction over here, you can, the packet is not going to travel. Packet is not going to travel in this path. Sorry. So however, here in this mechanism, if we have the conjunction also, packet is traveling here with some delay. But here it is avoiding this path. So this is the way of adaptive routing algorithm. And minimal and non-minimal. Minimal and non-minimal also, it is very similar one of static and adaptive. Minimal is nothing but it is going to select the shortest route. Non-minimal is nothing but it is going to goes with which is the route already decided in the source. So you can see here minimal. So very minimum distance it is going. But when you are going for the non-minimal, it will go in different path. Okay. And this is source and distributed. Source path is going to be, source routing algorithm is going to be decided when the packet is at source. So here you can see here ENES, nothing but these are all the way of direction. First it has to move to the east direction, then north direction, east direction, south. So it is the routing is fixed in the source event. So you can't change the route once the packet is started. But whereas in the distributed, you can change, depends on the router algorithm or router status. So once if you see here, so here the packet is moving east. So once it is packet dropped here, then it will, north one is dropped here. Then here it will move to this direction, north one. Then it will comes to the east direction. Then it will comes to the west direction. Sorry, south direction. Then it will comes to the east direction. Then it will goes to north and again north. Then it will goes to the local. So here the source even it is telling how the packet is going to move. Source, whenever the packet is starting from the source even, it will, the routing is decided. But in the adaptive, depends on the condition, you can change the routing path also. So these are the routing examples. So first one, XY direction manner routing algorithm. Nothing but it will travel either Y direction, then X direction, or it will travel X direction, then Y direction. So you can see here, first it will traveling the X, then it will move into the Y. So this is a source, and this is the destination. So 50% x direction and 50% y direction. Anyhow, it is going to through the x and y directions only. So first to x and y. So this x and y's are going whenever this block is here the path is blocked or congested, then it is moving 50% x and 50% y. So it will go here. It is not going to select this path. Now it is going to select this path, then it will go to the destination. Because this path is congested or this path traffic is more. So the summary of routing algorithm, deterministic or x and y are very simple, but it cannot give the shortest path. Adaptive is going to give the very shortest path, but if the packet is experiencing any traffic or congestion, there will be there will be facing of deadlock or live log. These type of problems you can face in the adaptive. So these are the latency, how it is going to increases. So for the simplicity or for the better results, most of the researchers are using deterministic routing algorithm. Next one, routing mechanisms. So what routing mechanisms, how the routing is fixing, how in terms of fixed as well as algorithmic routing. So fixed routing tables are nothing but, so based on the source event, it will fix the table. So once it processes to the source, which node it has to go, then which node it has to go, node 1 or node 3 or node 4. So before packet starting from the source, before even the entire directions are fixed. But whereas in algorithmic, so depends on the parameters, congestion depends on the traffic, the packet can change its direction. So there are two types of table-based routing mechanism. One is source and node. So each source is giving the table, and here each node is telling the table how the packet is moving from, whether it will goes to the adjacent node or whether it goes to the opposite node, how it is going to go in or routing, that will be decided by the routing table. And another routing is algorithmic routing. So instead of using table, algorithm can be used for the next route, because it can able to compensate or it can able to change the route depends on the traffic or depends on the congestion. So another type of building block will be switching. So switching, there will be two kind of switchings are there. Basically, if you divide, that is circuit switching and packet switching. Circuit switching is nothing but the packet is going to travel with proper dedicated wire or dedicated link. Once the link is established, then only the packet or data is going to be transferred. But whereas packet switching, the entire data or message divided into several packets, then the data is going to be moved. So by pictorial representation, you can understand better. So here you can see this is a configuration probe, nothing but link of wire, and this yellow is indicates data, circuit is indicating blue. Once data is reached to destination, you will get the acknowledgement again. So you can see initially header is started. So this header will goes to source to destination and link is established. Then header is moving, then link is established. Then header is moving, link is established. So once the link is established, then what will happen? Remaining data, whatever the remaining data it will be there, that will will flow from source to destination, nothing but 0 to 5. So here acknowledgement will come, nothing but 5 data destination will be ideal, so that once the acknowledgement is received, so source is going to send the data. Now data is sent to the destination. So like this, you can see the circuit switching. So circuit switching, you can able to provide the accuracy of the data, but you can see the latency, because to establish the link, between source to destination, it will take certain time. So here you can experience the delay, but accuracy will be more. Whereas in other switching, packet switching is classified into three switching, that will be uh, store and forward switching, and wormhole switching, and virtual cut through switching. So first one, you can see the store and forward. Store and forward is nothing but once the data is divided into several packets, these all the packets is going to store into the source node. Once all the data is came to the source node, then it will goes to the intermediate node. So you can see here, first 4 packets comes to the source, 4 packets come to the node, then it will move to the node, then it will goes to the destination. Nothing but all the data, all the packets, entire data, it is going to comes to the node, then only the data is going to be moved to the neighbor node. So you can see the store and forward again. So all the data will come to the neighbor node. Then again, all the data is comes to the neighbor node. Then all the data, it will go to the destination. So for cycle 0, this is the header, body and tail. For cycle 10, after 10 seconds or after 10 units of time, again the header, body bits, and tail. So like that, that store and forward switching, packet switching will be there. Then virtual cut through. So this virtual cut through is a similar kind of store and forward, but only the small difference is, so whenever the data packets are fully not reached, then only the header packet will start moving from the adjacent node. So how it will be, you can see, first header packet is moved to the source node, then body, and whenever the body packet is comes to the source, header will be moves to the adjacent node. So like this, if so, why you are going to this type of mechanism? Because so to reaching of all the packets in one node, it will consume the some delay. To avoid of that, so header is moving parallelly and body is also moving parallel. That you can assume here. So virtual cut through, how it will be. So first header is came, then body is came here, but header is comes to the adjacent node. So body comes to the adjacent node and header comes to the destination. Then body will come here, then tail bit will come here. So like that, you can able to save some delay. So this is another kind of packet switching, that is the wormhole switching. So wormhole switching is nothing but you are going to dividing the packets in terms of fits. Again, fit is nothing but physical unit in terms of bits of memory. Small, here you can see large packets are divided into small flits. So each flit its own having the numbering and it whether what is the meant for it is. So first one fit will come to the source node, then it will goes to the intermediate node. So like this, you can able to see the flit is moving to the destination node. Header is reached to destination. Where is the tail? Tail is in the source here. Because here, what is the advantages in this structure? In this structure, you need not to provide the maximum memory. Here, if you go for the virtual cut through, here every node it must have able to store the all the data. But here it is not required. Only one flit is coming and this flit is moving to the next one. So memory requirement is lesser than virtual cut through or lesser than store and forward. So here you can see in this one. So this one is blocked by someone. So you can see the header, one flit is moving here. So adjacent it is moving. So this one is completely full. Next it will goes to the next buffer. So again this is going to be full. It has to go for the next one. Okay. So like this, you can able to transfer the 6 flits. Only thing here, you are reducing the memory requirement, and data transferring also gets comparatively speeder than the virtual cut. And what is the importance of virtual channel here? So here, if you see, the channel is going to be blocked, or channel is going to be booked by some other task. So in this way, the flit cannot going to be transferred. So if you want to, the flit is going to be transferred from this node to this node. There is no connection, other connection. So in this manner, in this way of situation, you have to create the virtual channel. So virtual channel is used to combat the HOL block into wormhole. Like HOL block, and HOL block nothing but header line of block. Okay, header line of block. So this header is going to be blocked by the some other task, blocked by some other packet. So this you can overcome by using a virtual channel. So virtual channels are the multiple flit queues per one unit port, per one input port. So you can create the new virtual channels, and it can share with the physical channel. So that what will happen? The blocked flit, it can reach the destination. So you are reducing the packet delay. But what is the drawback here? You are dividing the physical channel into some virtual channel. So as this division will require some more power. So that is only the major drawback. But comparatively, you can decrease the packet delay. So how this one is blocked by some other, right? So how you are going to transferring the data, you can see by creating the virtual. So virtually you are created in previously, these are all the things in only one channel, but here you are going to create the physical channel as well as virtual. So this is a virtual channel based NOC. So each input port, there will be, when you are transferring the data for the network on chip, there will be a input port and output port and crossbar. So input port has to transfer the data to output through the crossbar. So these input ports are giving with the virtual channels. So these are the virtual channel routers. So how you are going to identifying the virtual channels? So depends on the different conditions. So virtual channel identifier and routing logic and virtual channel allocator, switch allocator. There are four stages. Whether I am giving, I would have given in the further slides. So, but whenever the packet is moving through the virtual channel, it should go with the 4 different blocks. That is routing block or routing logic identifier and virtual channel allocator and switch allocator. Okay. So by using of this, the packet is going from the input channel to output channel. So summary of switching techniques. So switching techniques, circuit switching, you can use the flit or packet, and path will be reserved is there, and buffer size will be small, and resource utilization is poor, because it is only going for the fixed path. Initially path will be created, then only packet will move. And yes, store and forward and virtual cut through and wormhole, you can use the good resource utilization, but you don't have the path reservation, but you can get the some delay here. So next building block of network concept will be flow control mechanism. How the data is flowing from source to destination. There will be two kind of flow control mechanism that will be here, bufferless and buffer. So bufferless nothing but each input port will be having the buffer to store the data, But some kind of mechanism, we are not creating any kind of buffer, because if you take the wormhole switching, so in the wormhole switching, you need not to store any kind of packets, because only one flit is going to be transferring from one node to another node. So this type of mechanism, you need not get any buffers. So this type of mechanism, we can call it as a bufferless. And If you go for the store and forward or circuit switching, you can use the buffered way of control mechanism. So bufferless flow control, how it will be? So first data is moving from one to other. So these are all the architecture of the buffer flow control mechanism. So if the memory is not proper, packet is not properly moved, so packet is going to be disrupted. That is only the problem in the buffered. When you are going for the buffered, there will be one mechanism, that is stop and go flow control. So data is continuously coming from source to destination within the, because here sender you have the buffer and receiver you have the buffer. So whatever the buffer in the sender, that will comes to the destination. So there is another kind of mechanism which will go for the outside of the buffer control mechanism. So this is whenever you are giving the flow control, you must have the acknowledge, that is positive acknowledge and negative acknowledge. If the data is properly received, answer. So if whenever you will get the proper acknowledgement or successful acknowledgement, then we can call it as a positive acknowledgement. Whenever you will get the data is not properly received, then node 2, here node 2 is going to give to the negative acknowledgement to the node 1. Nothing but whichever the packet is getting the negative acknowledgement, node 1 has to resend the again, because packet is not properly received. If it is properly received, there will be a positive acknowledgement. If it is not, negative acknowledgement will be there. So this is positive and negative based acknowledgements. So flow control mechanisms, basically we can see the buffer and bufferless acknowledgement or negative acknowledgement. So here credit based, nothing but using the buffers, on and off, nothing but you can use the small buffers or flip based buffers in the system. So next one, next the building block will be routing architecture. So there will be a, if you creating the network concept router, so you can see the data path and control path. Data path, it is going through the input buffers and switches and output buffers. And control path, nothing but before data transfer, the link has to be established. How the link is going to establish? Based on the route computation, virtual allocator and switch allocator. So these are the basic fundamental blocks for the control path. So here you can see the typical router includes these stages. Routing computation. Routing computation means how many nodes the packet is experiencing. So there each node is going to be calculating their how fan in fan out, or we can able to calculate the how many nodes it still has to go for the destination site. Next, virtual channel allocation. If the physical channel is blocked or booked by someone, it has to virtual channel has to allocate. Then once the virtual channel is allocated, proper switch has to allocate, because if the switch is not available, though you are providing the virtual channel, it is no use. Then switch traversal. Switch traversal is going to transfer the data from particular switch to destination. So in here you can see these are all the 4 basic stages for cycle 0. So first route computation will be done. Then cycle 0 header fit will be arrives to the first stage. In cycle 1, the route computation will be calculated and the head fit wheel is going to be starts into the next stage. Then cycle 2, it will go for the route virtual allocation. So header fit will come to this stage. Then cycle 3, it will goes to the switch allocation. Then cycle 4, it will goes to the switch travel. So once the header will goes to here, where is the body? Body will be at first position. Once the header will move to the last position, body will starts to the switch travel. That you can see here. So once the header fit will comes to here, body fit is going to be traverse the data. Finally, it will come to the tail fit. So these are the pipelined manner. The data header flit, body flit, tail flit is moving from the source to destination. And last one, the network interface. See the if you see the network based network on chip based architecture, so it will have the first core through the NI, again destination through the NI. So what is the role of NI here? Role NI is nothing but network interface. This network interface is responsible for packetization and depacketization. Packetization in source, depacketization in destination. Packetization nothing but message in the form of any manner. But these routers can support only the data in the form of packets or in the form of flits. So those flits or those packets is converted in the NI. So this we can call it as a transmit NI. This we can call it as a destination NI, network interface. So you can see transmitter side NI and receiver side NI. So the data is transferring from core to NI, then it will comes to the router. So here the data only, it is simply mentioned, but when you are coming to here, NI has to select what is the data type, nothing but it may be packet or flit, which is the source, where is the destination, and then what is the source address, and how many packets, and what is the packet size. So these are all the parameters it is mentioned in the NI. So it will come here, then it will goes to the nearby router. So from the nearby router, it will goes to the receiver side. So again, it will comes to the router through receiver side. So receiver NI it came, and then again it will depacketization, then it will goes to the memory. So like this, the packet is moving from the source to destination through the intermediate of NI network interfaces. So this is the slide of doing research in network on chip. So as network on chip is very simple for designing of future applications. So FPGA based network on chip is going to be used for the biomedical signal processing, because nowadays signal processing and speech processing, image processing, these are all the research domains are collaboratively as conducting through the VLSI based processors. So there, wherever the VLSI based processors, we can able to use the network on chip based concept. And again, advanced multi chip SoC architectures are required for the AI based applications. So AI or big data or blockchain. So these are all the technologies which will require the higher end of processors. Supercomputers, it requires the supercomputers. It's not like lower end processors. If you provide, there is no performance at all. So for the supercomputers, we can able to use the multi-core, multi-chip system on chip architectures we can use. And another important domain of network on chip is 3D, because whatever today we discussed, those are all the two-dimensional network on chip. So it is in the form of X and Y. So there is another direction which is the three-dimensional X, Y, Z. So these three-dimensional NOC is also one of the very important topic or research domain for the research. So these are the summary of today's what we discussed. So there will be a more solutions. There will be more problems with solutions available in the research community. So flexible to do the research with different kind of domains of other collaborative different kind of domains. So these are the references which we use for today's webinar. So any questions? Welcome.
Thank you, sir. That was a very informative session. Now, before winding up, I'd like to thank Dr. Ashok Kumar, sir, for your esteemed presence and cooperation. And if the attendees have any queries or doubts, you can directly ask sir or write in the chat box.
Yeah, feel free to you can query your doubts, or even I given my mail ID. If you want, you can share your doubts to that mail ID.
Okay, Jyotika, I think no more questions are there. I think you can wind up.
Excuse me, sir. Hello.
Yeah,
Hello.
yeah.
Yeah, sir, I have a question regarding IoT. So, sir, like IoT is developing day by day. So, sir, what are the challenges one could face, like for development of IoTs?
See, for development of IoTs, you can concentrate on the real time problems, because nowadays every system is going to be automated system. So when you are going to present or design a automated system, what are all the different problems you are facing? That you can identify any one of the problem and you can do your research.
Yes, sir.
For
Thank you.
example, yeah.
Yes, sir. Yes, sir. So, sir, how should like one? So, say for solving the problem, what should one mainly focus on? Like, is it the software part, or like is the combination of the AI as well as machine learning, or is it the concentration on? Is it in the hardware or is it in the software?
Yeah, that depends on your interest, because one cannot do all the different directions of research. You can select either network on chip, or you can select either IoT or big data or AI, ML. Because see, example I want to tell, like automated car. Automated car is started, but when you are coming for the practically, it is not. It's still in testing one. So there will be lot of permutations and combinations we have to give in the algorithm. So depends on your interest. You can select any one of the problem which the real time or society is facing. You can select it and work on it. And there will be research communities to help us.
Yes, sir. That's a lot of clear. Thank you so much.
Thank you.
Yeah, so we come to the end of the session.
Yeah, no, Jyotika, I think one question is there in the chat box.
Okay, please go on.
Yeah, when we consider our country, India, in regards of development in this topic, do you think India has enough knowledge and exposure to this topic?
Yeah, obviously. See, there will be a knowledge. The people, lot of people are there to providing the knowledge, and there will be a lot of fabrication units are there to do the research on this. So if you are going to do only simulation part, lot of softwares are available, and once it is designed, if you want to go for the fabrication or hardware part, so fab units also will be there. So India is also is the country where the people are having high level of talent. Once you should get into the community. Once if you get into the community, or if you go into the path, then you can able to know the who are all the experts available in the particular topic.
Okay, thank you, Ashok. Jyotika, you can wind up.
Yes, now we come to the end of our session. Thank you so much for joining us, sir, and thank you all for participating.
Thank you, Ashok.
Thank you, sir, and thank you once again for providing the nice opportunity. And because these type of opportunities only we can share knowledges to the
Yes,
whatever we done in the research.
Yes,
so
that's true. That's true, and that's how we share our research and motivate others to do research.
Yes, sir. Yes, sir.
Yes.
Yes, sir. Thank you, sir.
Okay, thank you.